So here we go. Let's get our notes out. Here we go. In the beginning here, there really isn't, I'm just gonna go through what he has already all written out, so unless you have some ancillary notes you wanna take, I'm just gonna explain kind of what he has done here. You are required to know the definitions. The cosecant, CSC, is the reciprocal of the sine. Now, that is absolutely critical because you don't have a cosecant button on your calculator. In order to do a cosecant on your calculator, you are going to have to know that it's 1 divided by sine. Okay? Cosecant, 1 divided by sine. Now, you know what a sine curve looks like. So I'm going to go ahead and just sketch a real quick little sine curve. You know that its amplitude is 1, and its period is 2 pi. That's a sine curve. If I take its reciprocal, then it is automatically going to have, the reciprocal is automatically going to have asymptotes at 0, pi, and 2 pi, because that's where the sine equals 0. And if the sine equals 0, then will 1 over sine be undefined? And undefined is graphed as vertical asymptotes. So we have these asymptotes, undefined at those points, and then we simply flip our curve. So the green thing is a picture of the cosecant. That's the graph of the cosecant. The reciprocal of the sine. Notice, or I didn't really draw more of it, but if I were to continue my sine curve, would you see that the cosecant is just going to be a long series of up parabolas and down parabolas? Next will be up and then down and so on. So the period of the cosecant is the same as the period of the sine, 2 pi. Cosecant, like tangent, has no amplitude because what does the cosecant do? Shoot up along its asymptote. So there's no amplitude to the cosecant. Now, the 1 and the -1 are important numbers, absolutely. That's where your parabolas are vertexed from, but that isn't the amplitude. Anybody have a question about that?
Well, like tangents, they had asymptotes, but they still had amplitude.
No, they don't have amplitude. Tangent does not have amplitude.
What was the thing called that were like halfway between like the middle of the period and like the asymptote, like it would be like 1 up?
Oh yeah, that wasn't amplitude. That was for us to get the size, the shape of our tangent curve correctly.
Oh.
Yeah. Now, the tangent and the cosecant can have a multiplier out in front, and that will change the steepness of the curve, but it doesn't have anything to do with the height of the curve. The amplitude's high.
Oh, okay.
All right. Now, guess what I'm going to do here for my secant? S-E-C. Secant. I'm going to graph 1 period of my cosine. Oops. And then I'm going to do exactly the same thing. So dash it in. Here is my cosine. Is that okay with everybody? Where will the asymptotes of the cosecant, or excuse me, of the secant be? Wherever the cosine is 0. Okay, wherever the cosine is 0. So this one's going to have an asymptote here, and here, and at 5 pi over 2, and so on and so on. So this piece of the secant is easy to see. It's that parabola flipped upside down. What's going on over here? Half of it, and then this will be the other half of it. just like when you graphed a cosine on 0 to 2 pi, its normal period, you have half a hill here and half a hill here. So you're gonna have half a parabola there and half a parabola there. Period's 2 pi. Does that make sense to everyone? Period's 2 pi and no amplitude. Cotangent is the reciprocal of the tangent. Now remember, this one I probably should put my unit circle up there so you can see it. If tangent is y over x, then cotangent will be x over y. Alright, what happens?
That's undefined.
That's undefined. So the cotan is going to have an asymptote at 0. The tangent does not have an asymptote at 0. But the cotangent does because it's x over y. Alright, what happens at pi over 2? The cotangent is 0. How about pi? Undefined again. How about 3 pi over 2? 0 again. And then we'll write back. Now, do you remember the shape of the tangent? The shape of the tangent was like this, right? The cotangent is like this. So in other words, while the tangent is always increasing, its reciprocal is always decreasing. Think about it. As numbers get bigger, like let's use whole numbers, 1, 2, 3, 4, what happens to their reciprocals? They get smaller. Yeah, that's what's happening. Now, it's a negative tangent shifted, because a negative tangent would have asymptotes at pi over 2. Yeah. So yes, it's a negative tangent
And this
shifted.
will have like
Yes.
the one thing.
Yes. So like this point right here, that's pi over 4, that's 1. What is the period of the cotangent? I've actually drawn too much. The period of the cotangent is pi, and it has no amplitude, just like the tangent does. All right, you gotta memorize these relationships, guys. And then I don't care if you memorize the curves or not, but memorize how to get the curves. So if you know cosecant is 1 over sine, you already know how to graph a sine, so you can graph a sine and then just flip it. All right, let's look at some problems now. Example 1. We're in our notes. Example 1. Which of the following is a vertical asymptote of 3 secant 2x? Now, here's our secant. Where are the vertical asymptotes in the secant? They're at pi over 2 and 3 pi over 2. Now, this is secant x. What happens when I put a 2 in there? What does that do? It divides the period. So if the original asymptotes were at pi over 2 and 3 pi over 2, where are you now going to have asymptotes? Pi over 4 and 3 pi over 4. So which of those is an option? C? Does that logic make sense to everyone? Remember, this guy divides the horizontal. So whatever the original x was, it's divided by 2. Multiplied by half. Which of the following is a vertical asymptote of 4 minus 2 cosecant pi x? Now, remember, the only thing in that equation, that big ugly equation, the only thing that impacts the x's is right there. Would you agree with me? That's in there and that's fine. That's gonna turn the picture upside down and all kinds of stuff, but it's not gonna change the asymptotes. The asymptotes are at x values. So what does that do? Divides by pi. So if you take all of these and divide by pi, are any of those in there? Looks like B. Because my asymptotes, oh wait, no, I divided by pi, not 2, I divided by pi, so yeah, it looks like 1D, because pi divided by pi would be 1. I divided by pi this time, not 2.
Well, you got C.
What's pi divided by pi? 1. What's 0 divided by pi?
Wait, isn't the period 2, like, the normal period is 2?
We're not doing it, we're saying where are the asymptotes? And I'm dividing by pi, so divide all your asymptotes by pi. Which of those numbers is in there? 1. It's the only one that's there. All right. 3 cosecant, so I'm back to this picture. This time it's 3 cosecant, 1/2 theta. The question deals with the range. Okay, which way is range? X or Y? Y. So in the normal picture, the range is from 1 to infinity, and from negative infinity to negative 1. Would everybody agree with that? Well, what does this number do? That multiplies the y's. So if this was a 1 in the original picture, it's now going to be a 3. So my range would be 3 to infinity, that's this part. And then what about this part? If that was negative 1, it's now down at negative 3. So that's negative infinity to negative 3.
What's the value?
Which of the following is a vertical asymptote? This is a cotangent question. So which of the following is a vertical asymptote of negative 5 cotangent 2 pi x? Now does this number have anything to do with the asymptotes? No. Asymptotes are at x values, so this is the only thing that's gonna do anything. And what's it gonna do? It's gonna divide all of the the asymptotes. It's gonna divide all of the asymptotes, right? Yep. So 0 divided by 2 pi, pi divided by 2 pi, 2 pi divided by 2 pi. Are any of those numbers in there? 1/2? Is that okay with everybody? See how easy that is? All right, so now we're going to solve some equations. This is what you did on your quiz, only your quiz was all sines and cosines and tangents. Now we're going to do exactly the same thing. Solving. All right, I want the point of intersection. So 4 cosecant x plus 3 equals 11. Everybody with me? And we are from 0 to 1. All right, let's solve it. 4 cosecant equals 8. Cosecant equals 2. Would you agree with that? else. I've done this for years and years and years, and I love doing it, but my brain does not function in cosecants. So I'm immediately gonna think of this as, if the cosecant is 2, then the sine must be 1/2. True statement? And now it's just like your quiz question. Where does the sine, all the way around the unit circle, where does the sine equal 1/2? At pi over 6 and 5 pi over 6? And those are the answers to the problem. Those are the places where the cosecant equals 2. Because the sine equals 1/2 and its reciprocal would be 2. See how easy that is? That is no different than what you've already done. All right, let's try the next one. While I'm erasing, get started on the next one. You want to find the points of intersection, so set them equal. That's how my brain is working. Is yours working that way? The problem is a secant problem. I go ahead and solve for the secant, just like I would solve for anything else. But if the secant is -2/1, then the cosine has to be -1/2. So somewhere on the unit circle, the cosine is -1/2, that's x. And if x is -1/2, then how big's that angle gotta be? 2 pi, well, pi over 3, but it's in quadrant 2, so 2 pi over 3, and 4 pi over 3. And those are our answers. Owen, you paying attention, sweetheart?
I am.
Okay.
Wait.
I got the same answer as you.
God bless you.
Wait, why on the other one sine and then that one you did cosine?
This is a cosecant problem, and this is a secant problem. All right, we gotta memorize that. Yeah. Okay. Now we're gonna do a cotangent problem. So I need a calculator for this. I want to know, all right, so 3 minus 1.7 cotangent, 0.5x minus 1 equals 2. All right, did I copy that right? And I want to know if it said equal to 2. Is that okay? So let's see what we got. -1.7 cotangent equals -1. So cotangent equals what is that, 10/17? Okay. Yeah. So then, if the this stuff right here, I'm gonna worry about that in a minute, whatever that is. But the tangent of it equals 17/10. All right, so let's take a minute, make sure everybody's digesting that. So this says, I've got some kind of angle out there somewhere. It's certainly not one of my special angles. But there's an angle out there, and his tangent is a positive 17/10. I don't know what it is, but I know where it is. Where is the tangent positive? Q1 and Q3. So here is going to be an angle, and here is going to be an angle. Would everyone agree with that? Now, I don't know, oh, someone's got my calculator, so I'm relying on you. Set your calculator in radians and do second tangent 17 tenths.
1.039.
All right, so this angle right here is 1.039. Would someone confirm that?
Yeah.
Okay,
Confirm.
1.039. So whatever this is, it's 1.039. Would you agree with that? That if I took the tangent of 1.039, I get 17 tenths. Okay? Now, what about this one down here? Well, that's supposed to be a straight line. This is also 1.039. This little angle right here. So what would be that whole angle to get me all the way around into quadrant 3? Yep, so what's 1.039 plus 5? 4.181 and 1.039. So here's what I need everybody to be with me on. I don't know what this is, but I know that whatever it is, it's equal to 1.039 or 4.181. Does that make sense to you?
So that's just when you have two answers.
Now, I gotta find x. I have found the angle, but I don't know what x is. So whatever is in this parentheses, 0.5x minus 1, it has to equal 1.039, or it has to equal 4.181. Does that make sense to you? All right, so let's figure out, solve this and tell me what my x values are. These are the actual angles that make this a true statement, but that angle has a different name. So I need you to tell me what those are. What are the x values? So add 1 and divide by 0.5. 1.02? I have no idea, I have no calculator. And 2.59? So right here, solve this. Add 1, divide by, what? Did you divide by 0.5?
What are we doing?
We're solving this equation, like first grade, okay? Solve that equation.
First grade.
Add 1 and divide by 0.5.
I was doing like 8 times 6 in first grade.
Aren't you cool?
Yeah, the rocket math.
Aren't you
Tell me
cool?
what you got, I don't have a calculator.
I don't even know what it was. I had a little comic in math, bro.
Meredith,
Magazine.
add 1, divide by 0.5, what'd you get?
I got 10.362.
7 point,
10.362.
10.362.
And then 4.078.
Okay, so for this one, you got 4.078,
078.
and for this one, you got 10.362.
362.
Right there, solve that equation. Those two equations. All right? Now, what was the domain of the problem? Does this answer fit in the domain? No, because 2 pi is like 6.28. So this one doesn't work, and the only answer to the problem is that one right there. Remember, you're solving for x. So once we figured out what our angle was, these were our angles. Once we figured out what those were, then we could go back and solve for x. All right, let's go to the back of page 3. We have not done any of these together, but I think you can figure out number 1. We're on the back of page 3. Would you and your partner, these are no calculator, would you and your partner see if you can find the values for the cotangent, secant, cosecant of these angles?
Why is this not a problem on my calculator?
We're not doing this on our calculator. This is without calculator. So think about it. Could you find the tangent of 3 pi over 4? Actually, you might have that memorized. The tangent of 3 pi over 4 is -1. What's the reciprocal of -1? -1. So the answer to this one is -1. Can you find the cosine of 5 pi over 3? Find it, and then take its reciprocal. Right, Kate?
Oh, no, I'm just trying to do it in my head.
Oh, figure it out. So you want to find the cosine, this is secant, reciprocal of secant is cosine. So you find the cosine of 5 pi over 3, and then flip it. So what's the cosine of 5 pi over 3? 1/2. So the reciprocal would be
Would it be negative to it?
5 pi over 3, quadrant 4, cosine's positive.
But would it, like, we don't ever change the sign?
No, we're just flipping the numbers. So cosine is 1 over 2, secant will be 2 over 1.
Lock in.
If the cosine is negative, its reciprocal
Is it
will be
CS?
negative. If it's positive, its reciprocal will be positive.
Just CS. The letters C, S.
CSC, cosecant.
Yeah,
CSC. All right, what is the sine of 7 pi over 6? -1/2. So therefore, the cosecant is -2. Remember when we talked about how important the unit circle is? It is still important.
Don't make a donut sandwich.
Okay,
You can put that in the
let's
donut.
look at let's look at number 2. F is the cosine, and G is its reciprocal, the secant. So if the cosine is 0.235, what will the secant be? 1 over 0.235, whatever that is. That'll be some other decimal. But remember, they're reciprocal. So if you know your cosine, then you automatically know the secant, it's 1 over. So whatever 1 over 0.235 equals, that is your secant. The parent function, cosecant theta, is stretched by a factor of 2 and shifted up 5 units. Write an equation for this new function. Okay, so we got our regular cosecant function, and we just learned this, so I'm going to do a quick sketch here. Okay, remember that from earlier? That's your cosecant, reciprocal of sine. Now, we're going to take this thing and stretch it by a factor of 2, and then shift it up 5. Now, that's a little unclear, but I think they mean by vertically stretch. We're going to vertically stretch it by a factor of 2 and move it up 5. If if we are vertically stretching it by a factor of 2, then these won't be 1 and -1 anymore. They will be 2 and -2. Right? We've stretched it, because we've stretched the sine curve, and that's pulled that up. Now, we've moved it up 5. So we picked up this parabola and moved it up 5. So where is it now? 7. And this one also came up 5. So where is it now? 3. So what is our range? Well, now we're going from 7 to infinity on this parabola. And then on this one, we're going from -infinity to 3. Does that make sense to you? No asymptotes have changed, because the only thing we've altered is the verticalness of the picture. All right, let's finish this page. Which of the following is equivalent to cotangent? Now, somebody said it earlier, that a cotangent is an upside down tangent, right? It's upside down. So would you agree that looking at these, it's either A or B? But there's another difference, besides direction, there's another difference between tan and cotan. And that is where its asymptotes are located. So it can't be A, would you agree with me? But if you take a tangent and shift it pi over 2 to the right, then its asymptotes are gonna be at pi and 2 pi, and that's exactly where your cotangent is, so it is B. Does that logic make sense to you? You're just beginning your tangent and cotangent, your cotangent, secant, and cosecant journey. All right, number 5. Which of the following has no solution? All right, take a minute. Don't use your calculator. Just take a minute and see if you can reason out which of those problems has no solution. Anybody have a wild guess? A. A has no solution. Why not, Ellen Pat?
You said wild guess, and so I threw it again.
Does anybody know why it's A?
It's his lucky day.
Alex?
Because you get the cosecant to equal 2/5, and that can't be right because an inverse of something less or equal to 1 can't be less or equal to 1.
I like
If
ones.
the cosecant is 2/5, then doesn't that automatically mean the sine is 5/2? And can sines be 5/2? No, sines can't be bigger than 1. And if sines can't be bigger than 1, cosecants can't be less than 1. And the same is true of the cosine and secant. There's nothing wrong with this. Why is there nothing wrong with this? Because this says the cosine is -1/4. Is that legit? Yeah, I don't know what it is. I don't know what angle that is, but that can happen. And And then of course the cotangent can be 0, because when you graph it, it crosses the x-axis. So of course that's it. So it is D. All right, this homework, what section are we in here? 311. 311 is due on Wednesday. 311 due on Wednesday.